All right. We are talking about section 10.1, ellipses. Okay, ellipses. Well, we know what an ellipse is. We'll start with a circle. Let's just remind ourselves that you have a circle radius r, okay? Then and with some center h comma k, okay? Then the standard form of the circle is x minus h squared plus y minus k squared equals r squared, okay? That would be the standard form of a circle, all right? H comma k is the center, r is the radius, okay? So that's the standard form of a circle. So we want to learn some of these other geometric figures. So the next one we're going to talk about is an ellipse, okay? And a circle, the definition is a circle is a set of points that are equidistant from a given point called the center. That's a formal definition for a circle. It's a set of points x comma y that are an equal distance from the center of the circle, h comma k. Well, so now we want to define what we mean by an ellipse. So an ellipse is a set of points x comma y, all right? And we're on page 908, by the way. Page 908. So again, read your book, as usual. Read your book. Set of all points x, y in a plane such that the sum of the distances, set of all points x, y, such that the sum of the distances, okay? Between x, y, and two fixed points is a constant. Between that point x comma y and two fixed points is a constant. Okay? The two fixed points are called the foci. So you might have an ellipse that looks like this. There's a focus. This is the focus. Okay? Or it could be oriented like this. Okay? There's a focus. And there's a focus. Okay? So an ellipse can have either and really you can have any point of orientation, but we're going to talk about two different ellipses. One has a horizontal major axis. Horizontal major axis. And the other one will have a vertical major axis. Okay? So the major axis is just the axis that goes through the foci. Okay? So there would be my major axis. Okay? This one would have a major axis that's horizontal. Okay? The major axis is nothing more than the axis that goes through the two foci. Okay? You got two focuses again. Set of points. So what we're saying is if I identify some point x comma y on the ellipse, that point, if I add up this distance and that distance, no matter where I move that point around the focus, the sum of those two distances remains the same. That's what it means to be an ellipse. And you could draw one. If you took a thumbtack and put right here, and a thumbtack and put right here, and you took a piece of string on a pencil and you just traced out and kept that same distance, the sum of those two distances, D1 and D2, what I'm saying is these two distances, D1 plus D2, that distance doesn't change as I trace this thing x comma y all the way around this ellipse. The sum of those two distances, if these were two thumbtacks with a piece of string between them, I could trace the whole ellipse, and the sum D1 plus D2 wouldn't change, okay? And that would trace out an ellipse exactly. That's what an ellipse is, okay? And again, we're gonna look at two different things. We're gonna look at ellipses with a horizontal major axis, and we're gonna consider ellipses that have a vertical major axis. This is called the center of the ellipse for obvious reasons, right? And you also have a minor axis. This is the minor axis. Minor axis, okay? That would be the minor axis. These 2 points where the major axis touches the ellipse are called the vertices. Right here and right here. Where the major axis actually touches the ellipse, those are called the vertices of the ellipse, okay? And we've got nice equations for this. And again, read this section. It's really important that you read. If I've got a major axis, if it's on the x-axis, the equation, so this is the one where the major axis is on the x-axis. And so the equation of the ellipse would be x squared over a squared plus y squared over b squared equals 1. And if the major axis is on the y-axis, x squared over b squared, y squared over a squared equals 1. Those would be my two standard forms, okay? If the major axis is on the x-axis, it'll be x squared over a squared plus y squared over b squared equals 1. If the major axis is the y-axis, it'll be x squared over b squared. Y squared over a squared equals 1. And for both of these things, c squared is going to be a squared minus b squared, okay? And c is the distance from the center to the vertice. C would be the distance. Well, no. C is going to be the distance from the center of the thing to the focus. Okay, C is going to be the distance from the center to the focus, where C is the distance from center to focus. So, if my focus was right here and right there, this distance right here would be C. Or this distance right here would be C. Again, from here to here, C, or from here to here would be C. C is the distance from the center to the focus, or the distance from the center to that focus. That's C. And C will, and for both of those cases, C squared is going to be equal to a squared minus b squared. Okay? C squared would be a squared minus b squared. All right? Now, A is always going to be bigger than B. Okay? A is greater than 0, B is greater than 0, and C is greater than 0. And A will always be greater than B. 3 things to keep in mind. Those are all facts. So again, look at this whole chart. They do go into it in more detail on page 9 and 10. That's all I'm gonna say, but make sure you read that chart and understand it on page 9 and 10. So that's where we're starting at. You can have these ellipses that have either a vertical or a horizontal major axis. And again, the major axis is the axis that goes through the foci. It stops at the vertices. One vertice is right here, the other vertice is right here. Okay? Then you have the minor axis. The minor axis is always shorter than the major axis for any ellipse. Okay? So with all that in mind, example 1. Example 1, this is on page 911. They ask us to, given x squared over 16 plus y squared over 9 equals 1. Okay? They want us to graph it. They want us to identify the center vertices and foci. Identify center, vertices, and foci. Okay? identify the center, the vertices, and the foci. Well, the easiest thing to do first, in this case, is probably just to graph X and Y, and that's gonna help us determine the rest of that stuff. So, when you've got a ellipse, and both of these cases, x squared over a squared plus y squared over b squared equals 1, and x squared over b squared plus y squared over a squared equals 1, both of those are centered at the origin. So both are centered at origin. Both of those two equations are based on something centered at the origin. So my center is at the origin. So 1, 2, 3, 4, 5, 2, 3, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay? So when they're centered at the origin, life is nice. When they're centered at the origin, life is nice. What do I mean? Well, to graph this thing, suppose y was 0. Suppose y was 0. So y squared over 9, that would go away. So if y equals 0, then the equation simply becomes x squared over 16 equals 1. That says x squared equals 16. Well, the square root of 16 is plus or minus 4, so I'll have negative 4, positive 4. The other way is if x were equal to 0. If x equals 0, this part goes away. So that goes away, you have y squared equals 9. To solve y squared equals 9, y is plus or minus 3. So plus or minus 3. So you immediately get the ellipse. This thing is elongated. The major axis is definitely on the x-axis, right? The major axis is always your longer axis. So the major axis is on the x-axis. So the foci are going to be on the x-axis also. But graphing it was really easy. If it's centered at the origin, this always works. Let y be 0, you'll have x squared equals 16. X is plus or minus 4, so positive 4, negative 4. If x is 0, y squared is 9, so y is plus or minus 3, negative 3 and positive 3. Draw your ellipse. It's elongated along the x-axis. The major axis is on the x-axis. So, the center, we've already said that in either one of those two things, the center is 0, 0. That's easy. That's one of the things they ask us to find. They want us to find the vertices. Well, we've identified the vertices. Negative and positive 4. So the vertices are negative 4, comma 0, and positive 4, comma 0. Those are my two vertices. Okay. Next, I got to determine my foci. Okay. My foci, I'll use that formula to find c. So c squared equals a squared minus b squared. So again, I had x squared over 16 plus y squared over 9 equals 1. So I've got this situation. Again, the a is always bigger than b. So x squared over a squared plus y squared over b squared equals 1. That is a ellipse with a horizontal major axis. So a must be the square root of 16. So a was 4 and b is 3. 4 squared gives you 16. 3 squared gives you 9. A is 4, b is 3. So c squared is a squared minus b squared. 16 minus b squared, 9. That's 7. So c is the square root of 7. So the square root of 7, you can take your calculator. The square root of 7 is something a little bigger than square root of 4. Let's say 2.5, 2.6, I don't know. I'm going to call it 2.6. So square root of 7 would be about right here. Negative square root of 7 would be about right here. Those are the foci. I got to focus here and focus there. At positive square root of 7 and negative square root of 7. The vertices we've already identified, so these were the foci. So negative square root of 7, 0. Positive square root of 7, 0. Those would be my foci. So we've done everything. We've graphed it, we've identified the center, the vertices, and the foci. Okay. Nothing hard about that. right? That's example one. We can clearly see that an ellipse, just like a circle, the equation of an ellipse is not a function because it doesn't pass the vertical line test, just like the equation of a circle does not define y as a function of x because, again, they failed the vertical line test. So equations of ellipse, equations of a circle are not functions. Example two. Example two on the next page. They say given 25x squared, they say plus 9y squared equals 225. They say graph. They want us to find center. They want us to find vertices, minor axis endpoints. Vertices, minor axis endpoints. And they want us to find foci. Okay. Well, again, if I remember the general form of that, or the standard form of the ellipse, it was this, or this. Those were my standard forms, okay? One with a horizontal major axis, one with a vertical major axis, okay? So the essential feature of both of these standard forms is they're equal to 1. For an ellipse in standard form, it must always be equal to 1. So that's what I've got to do to this first. I've got to write it in standard form. So I take 25x squared plus 9y squared equals 225. That's not equal to 1. To make it equal to 1, I got to divide by 225. But if I do it there, I've got to do it everywhere. So I divide all terms by 225 because it's got to be equal to 1 if it's in standard form. Well, 25 goes into 225 9 times. So x squared over 9. 9 goes into 225 25 times. So y squared over 25, that's equal to 1. Now it's in standard form. Okay? So since it's in standard form, I can see, and again, I said that for all these forms, the A is always going to be bigger than the B. Okay? So x squared over b squared plus y squared over a squared equals 1. So A must be 5, the B must be 3. A must be 5 and B must be 3. So we've got a ellipse in this form, which means I'll have a vertical major axis now. Well, let's graph it. X, Y. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. So I'm going to do the same trick. Let x be 0, y squared is 25, so y is plus or minus 5. Let y be 0, then x is 9. X squared is 9, right? X squared would be 9, and so x is plus or minus 3. So I see my ellipse, and I can definitely see that I now have a vertical major axis, okay? So they wanted us to graph it, we've done that. They wanted us to find the center. The center, again, is 0, 0. They wanted us to find the vertices. Vertices are the two endpoints on the major axis. So the vertices would be 0, 5, and 0, negative 5. The vertices will be the endpoints on the major axis. I said that A is 5 and B is 3, so C squared is A squared minus B squared. A squared is 25 minus B squared, 9. So C squared equals 16, so C equals plus or minus 4. So again, C is the distance from the center to the foci. So I'll go 1, 2, 3, 4 points, 4 places here. From the center, 1, 2, 3, 4 places along the major axis. So my vertex, for my foci rather, my foci will be 0, 4, and 0, negative 4. Okay? They also wanted the minor axis endpoints. So not the major axis endpoints. I did that with the vertices. The minor axis endpoints would be here and here. So the minor axis endpoints will be right here at negative 3, 0, and right here at positive 3, 0. Those would be my major and minor axis endpoints. All right. So nothing hard about this. You just got to understand those basic forms. You've got to understand that the A is greater than B. So if X, well, that's pretty obvious. I'm going to leave that at that. Now, so far, those two examples we've been looking at, we've been graphing these ellipses that are centered at the origin. Well, ellipses don't have to be centered at the origin. They can be centered at any point in the plane. They can be centered at any point in the XY plane. So now we're going to look at ellipses centered at H comma K. Ellipse centered at H comma K. So now, X minus H squared over A squared plus Y minus K squared over B squared equals 1. Okay? That's going to be, and again, you got to remember A is greater than B. So the center will be H comma K. Okay? And to get the, this is all on page 913. Page 913. We kind of see how this works now, right? Wherever your center is at, to get to the foci, you'll just take your center and you'll add C. So once you figure out what C is, you'll take 1, 2, 3, 4. C was 4, plus or minus 4. So along my major axis, once I know where my center is, I'll add 4. I'll go 4 units vertically. That'll be one of the foci. From the center, I'll go 4 units down. If I have a vertical major axis, that's how I'll find the center. So when you've got a ellipse centered at H comma K, and again, this is the one where you have a horizontal major axis. It's just like before. Okay, and then we're going to look at the second case where we have X minus H squared over B squared plus Y minus K squared over A squared equals 1. So this is going to be major axis vertical. Those are the two situations that we have with these ellipses. So again, the center is going to be HK in both cases. But to find the foci, okay, the foci, when I have a horizontal major axis, all right, when I have a horizontal major axis, I'm going to add C. Again, if I have well, this is the vertical. If I have a vertical major axis, what did I do to get the foci? I added this C equals plus minus 4 to my center. And again, only in the Y coordinate, because I just went up 1, 2, 3, 4 units in the Y coordinate, was where I added the C to my center. So for the foci, since I got that one sitting right there, whatever my center was, my foci is I'm gonna add C to that to get my foci. And then I'm gonna say H K minus C. So I should say K plus C here. If I've got a vertical major axis, to get that foci, I added C to the Y coordinate to get that foci. I added C to the y coordinate to get the foci. If I have a horizontal major axis, I'm going to add c to the x coordinate to get my foci. That's how it's going to work. Okay? That's how I'll find my foci. And again, all this is spelled out for you clearly on page 913. So read that, okay? Read that. And let's just do an example that will illustrate this. And I think it'll become clear. Okay. Well, we're at example 3. So they give us an ellipse. So they say x minus 3 squared over 16 plus y plus 2 squared over 25 equals 1. So same directions. They want us to graph it, find vertices, center, endpoints of minor axis. Graph it, find the vertices, center, endpoints of minor axis. That's what they want us to do. Okay? Graph the thing, find the vertices, the center, endpoints of the minor axis. Okay? Well, again, x minus 3 squared over 16, y plus 2 squared over 25 equals 1. That looks like this version. Yeah, right here. That looks like this version. So h comma k is my center. So my center, x minus h, so h must be 3. Y minus k, since I have y plus 2, k must have been a negative 2. So I've got a center of 3, negative 2. So x, y, 1, 2, 4, 6, 1, 2, 3, 4, 5, 6. 2, 3. So the center was at 3, negative 2. Over 3, down negative 2. Okay? Well, again, it looks like that. So the B must be a 4. B is 4. A is the square root of 25. A must be 5. Okay? A is the square root of 25. So the A must be 5. Okay? So I plotted my center. All right? And I'm going to count. Since A is 5, we've seen how these things work. Start from the center. Go up 1, 2, 3, 4, 5. So I'm adding A to the center. And right here, I'll go down 5. 1, 2, 3, 4, 5. Okay? Because I've got a vertical. Went down a little too much. I'm doing this by hand, so. If you do this on graph paper, it'll work out perfectly. And then B is 4. So I start at the center horizontally. I go 1, 2, 3, 4. And then I go in this direction. 1, 2, 3, 4. So there's my ellipse. It's elongated vertical. Okay? It's elongated vertical. So they wanted the endpoints of my minor axis. Well, that'll be this point right here, which is negative 1, negative 2. And this point right here, this was at 7, I think. 7 comma negative 2. So endpoints of the minor axis would be negative 1, negative 2, and 7, negative 2. That'll be the endpoints of the minor axis. We've already said what the center is. The vertices are just going to be right here. So that was at 3, 3. That's one vertice. I got another vertice down here. That was negative 7. and that one's gonna be at 3, -7. Okay? Did they ask me for foci? Yeah, they wanted, did they ask me for foci? They didn't ask me for foci, but I could find them, right? So c squared equals a squared minus b squared. A squared would be 25 minus b squared, 16. C squared equals 9. C equals plus or minus 3. So I start at my center, I'll go up 1, 2, 3. There's one foci. It's at 3, 1. I go down 3, 1, 2, 3. That's right here. 3, -5. Those would be my foci. Nothing hard about it. Now I cannot, when a ellipse is centered at the somewhere other than the origin, I can't do that trick I did before. When y is 0, you just get this equals 1. When x is 0, you get that equals 1. That does not work anymore. That little trick only works when the center is 0, 0. So if the center is not 0, 0, there's going to be our method. We're going to plot the center. Then we're going to use our knowledge of A and B to get the endpoints on the major and minor axis respectively. Then we can calculate the foci and find everything else we need. Okay? All right. Next example, example 4. Example 4, they give me an ellipse, 3x squared plus 7y squared. 3x squared plus 7y squared, plus 6x minus 28y. 6x minus 28y plus 10 equals 0. There's an ellipse. Well, I know it's an ellipse because the highest degree term I see on x is 2, the highest degree term I see on y is 2. Whatever the degree, the highest degree on both x and y is 2, and they're added, an x squared term plus a y squared term, then it's going to be an ellipse. Okay? Whenever the highest degree is 2 on both x and y, and those two highest degree terms are added together, the equation must be some type of ellipse. Okay? But my problem is it's not in standard form, and what we want to do is put it in standard form. So let's go ahead and gather the x terms together. 3x squared plus 6x. I'm going to gather those together. Gather the y terms together. 7y squared minus 28y. And this 10, I'm going to take it to the other side. I'm going to subtract 10 from both sides. So what I want to do is I'm going to try to complete the square on both the x and the y terms first. I'm trying to put it in standard form. So to complete the square, the first thing I've got to do is I need a 1 in front of x squared, so I'm going to factor out a 3. 3 times x squared makes 3x squared. 3 times a positive 2x. 3 times 2x would make a positive 6x, right? And I'm going to leave some space here because I'm going to figure out what it takes. What do I need to add here to make the stuff in parentheses a perfect square trinomial? I'm completing the square on the x terms only. The 3 I pulled out, so now I'm going to complete the square on what's left. Same thing here. I'm going to pull out the 7. And I'll have y squared minus 4y. And I'm going to leave some space because what I'm trying to do is I'm trying to figure out what I need to add here to make that a perfect square trinomial. Okay? And on the other side, all I've got left on the other side is still that negative 10. Okay? But again, I'm trying to create a perfect square trinomial here, figure out what to add to do that, and I need to figure out what to add right here to make this a perfect square trinomial. Okay? So, if you recall completing the square, I look at the coefficient of x to the first power. There's the x to the first power term. So I've got a positive 2. Half of positive 2 is positive 1. And you have to square it. Positive 1 squared gives me a 1. So I added 1 to make that a perfect square trinomial. Now there's a 3 outside, so 3 times 1 makes a 3. So really when I put the plus 1 here, the effect it had was really I'm adding 3 because 3 times a positive 1 makes a positive 3. Well, if I added 3 on this side, I've got to add 3 on that side. Okay? If I added 3 on that side, I've got to add 3 on this side. Okay? So I'll look at the second one. I've got a negative 4 in front of y to the first power. Well, half of negative 4 is negative 2, but again, I've got to square it. Negative 2 squared is 4, so I need to add 4 to make this a perfect square trinomial. Well, there's a 7 here, so 7 times 4 makes 28. So by putting a plus 4 here, really I added 28. So since I added 28 on one side, whatever you do to the equation, you do the exact same thing on the other side. I've got to add 28 to keep it balanced. So there's where I'm at. I've completed the square on both the x terms. I've completed the square on the y terms. Okay? Now, I completed the square, so I have a perfect square trinomial here. I completed the square here, so I'm going to have a perfect square trinomial here. Over here, negative 10 plus 3 is 7, negative 7. Negative 7 plus 28 makes 21. So that stuff simplifies to 21. Okay? Now, when you complete the square, the factoring comes for free. There's got to be an x here. There's got to be a y there. The only question is what goes here. Well, half of a positive 2 is a positive 1. That's what goes there. The factoring comes for free when you complete the square. You got the y here. Half of a negative 4 is a negative 2. So y minus 2 squared gives you that. And you can check yourself if you want to. Take y minus 2 times y minus 2, it'll give you that. Take x plus 1 times x plus 1, it'll give you that. But the factoring always comes for free when you complete the square. All right. It's almost in the form of a standard form of an equation of an ellipse, but again, I should have a 1 if it's in the right form. All ellipses in standard form are equal to 1. So to get a 1 here, I have to divide by 21. If I do it there, I've got to do it everywhere. Whatever you do to one term, you do everything, the same thing to every term on both sides. Well, 3 goes into 21, 7. 7 goes into 21, 3. Now it's in standard form. That is an ellipse in standard form. Okay? So we've done part A. We've written the ellipse in standard form. The center of the ellipse, x minus h, y minus k. The center would be at negative 1 comma 2. Okay? A is going to be the square root of 7. B will be the square root of 3. And we can identify the center, the vertices, and endpoints. So I'll leave the rest of that to you. Once you get it in standard form, those other things should be pretty straightforward. We've done 3 examples of those already. So I'm going to leave the rest of that to you. Okay? What if they did the other way? So we've done several examples. Again, we get the equation of ellipse, we have to determine the vertices, the endpoints of the major or minor axis, the foci, etc. They gave us the equation of the ellipse, and they made us find those things. So we know how to do that now. What if they gave us the opposite, though? Example 5. Example 5, they say find the standard form of an equation, the standard form of the ellipse with, they say, vertices. They give us vertices 4 comma 2 and negative 4 comma 2. And they give us foci, square root of 15, comma 2, and negative square root of 15, comma 2. So all they gave us was the vertices, and they gave us the foci, and they want us to write the equation of the ellipse. Okay? Well, let's see what they gave us. X and Y axis. Okay? Let's plot those points. Let's plot those points. So, 4 comma 2, negative 4 comma 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. 4, negative 2, right here. Negative 4, 4, 2, I'm sorry. 4, 2, right here. Negative 4, 2, right here. Those are my vertices. So that has to be the major axis, okay? Foci is square root of 15 to, square root of 15 is, what about 3.7, right? Take your calculator, the square root of 15 should be 3.7, comma 2, 3.567, somewhere in there, right? So those would be my foci. So since I started from 0 to go to the square root of 15, that means that C is the square root of 15, right? C is the square root of 15. And since I started from here to go to 4,2 and from here to go to negative 4,2, that means that the center of this thing is right here at 0, 2, right? So A is the distance from the center to the vertices, so I go from here to here, there's 4 units, so A must have been 4. So they gave me A and they gave me C, right? Well, C squared equals A squared minus B squared. C squared would be square root of 15 squared, or 15. A squared would be 4 squared, or 16, minus B squared. Subtract 16 from both sides, negative 1 equals negative B squared. So B squared equals 1, so B equals 1. So B is 1. So there's the center. So if B is 1, I go 1 unit up and I go 1 unit down to identify my endpoints of my major, or my minor axis rather. Those have to be the endpoints of the minor axis, okay? And so I can actually graph this stupid thing. That has to be my doggone ellipse, okay? And again, the center was at 0, 2. So again, x minus h squared, y minus k squared. Since I have a horizontal major axis, the a goes here, 4 squared makes 16. The y goes here. Again, b squared, 1 squared would make a 1, and I know what my center is. X minus 0, so really it's x squared. Y minus k, but again, 0, comma, h, comma, k must be 2. So that has to be the equation of the ellipse. Okay? That has, and really, y minus 2 over 1, anything divided by 1 is itself, right? And e equals 1. All ellipses will be equal to 1 if they're in standard form. Equals 1. All ellipses in standard form are equal to 1. So there's the equation of my ellipse. There's the equation of my ellipse. Okay? Again, the distance from the center to one of the vertices, that length is always going to be A on your major axis. The distance from the center to one of your endpoints on your minor axis, that distance is going to be B. And again, C is the distance from the center to one of the two foci. The distance from the center to a foci is always going to be C. So C was square root of 15 and the A had to be 4. Once you know what C and A are, you can find B. Once you know A, B, and C, and you know the center, you can write the equation of the ellipse. Okay? All right. So now we know, given this other information, how to actually determine the equation of the ellipse. So that was a little bit different. They made us do it kind of backwards of what we've been doing. They've given us the equation a bunch of times, asking us to find that information. But this time they gave us the information and asked us to find the equation. Next thing we're going to talk about is eccentricity. Eccentricity of an ellipse. And this is on page 917. Page 917. Okay? And I'm not going to write it all out because really it's based on those same stuff we've been talking about. So we're talking about ellipses centered at some center h comma k, right? And the eccentricity of an ellipse is the degree of elongation of the ellipse. Okay? The eccentricity of an ellipse is the degree of the elongation of an ellipse. So, and E, this is going to be eccentricity. Eccentricity. It's going to be denoted by E. E is going to be C over A. The eccentricity will always be C over A. And E is gonna be greater than 0, but less than 1. Okay? The eccentricity will always be a number between 0 and 1. Okay? And the closer it is to E, the more elongated the ellipse is. Well, the closer it is to 1, I'm sorry. So the closer the eccentricity is to 1, the more elongated the ellipse is. So if I've got an ellipse that looks like that versus an ellipse that looks like this, okay? This one has more eccentricity. So this one might have E approximately 0.8. This one might have E approximately 0.2. Okay? The closer that E is, that value gets to 1, the more elongated the ellipse is. The closer it is to 0, that ellipse is closer to a circle. Okay? It doesn't have a lot of elongation at all. Okay? So that's called the eccentricity of an ellipse. Okay? So with that in mind, example 7, you know what? Example 7 is pretty straightforward. They're just using that formula, E equals C over A. So they give you the eccentricity, and they ask you to find the distance. So I'm going to leave that one to you. Example 7, I'm going to let you do it. It's not hard. If you have any problems, let me know and I will record it and do it. But that pretty much concludes what we're going to do in section 10.1.